Hello everyone. Let's continue this class 5. Okay. So last class we introduced some typical distributions like a Bernoulli distribution and a binomial distribution. So for Bernoulli distribution is just a 1-0 distribution. Like x is equal 1 or 0. And the probability is P or Q. And the variance and the mean and the variance of Bernoulli distribution is this: mu equal P, and the variance sigma square equal PQ. So you can get them. You can prove. You can get them by the definition for mean and variance, right? So let's say. So let's review how to get those things. We say mean mu equal x. So here mean means average. So how can we find the average in statistics? It's just equal this number multiplied the probability, right? Then add those things up. So the variance sigma square is average for those things, x minus mu square. So the average for those is just x minus mu square can be this number, then multiply the probability, right? So plus add them up. Okay. So then, so if we try in general try many times, then the number of success for binomial distribution. So for binomial distribution, we just check the probability that the x equal k, that the good thing or this thing can happen k times. So this probability is this thing happen k times, so p times p, so happen k times, so pq. So q not happen n minus k time. And so we so from n times we just pick k times. For those k times, this thing happen, right? So we have so many ways from n choose k. Okay. So we call this a binomial distribution. And by the way, we call this number, this coefficient n choose k as binomial coefficient, right? Binomial. So this we call this name just come from binomial distribution. This is coefficient for binomial distribution, right? So we call this number as a binomial coefficient. Okay, so for binomial distribution, we have mean and variance. This mean is n mu and variance just n pq. So we can regard this is just the variance and mean and variance of Bernoulli distribution multiply n, because we just try n times. Okay. So now let's check this problem. So in our first quiz, we have 20 questions. So each with 4 choices, so A, B, C, D. So this means you can pick the correct answer is 1 over 4. So now let's check this probability. What you can get exactly 10 questions correctly. Okay, so such a probability we can regard this is a good thing or happen 10 times. So among 20 trials, 20 questions, you answer 10 questions correctly. So correctly is 1/4. So here we have 4 choices, A, B, C, D, right? So correctly, this thing happened 10 times. And not correctly, so 3/4. Say 3/4 happened 10 times. So then we just have have 10 questions correctly, answer 10 questions correctly. So this 10 question can be this 10 question or other 10 questions, right? So we just have so many ways. From 20 questions, we just pick 10 questions correctly, right? Okay. So this is, we say this is the exact equal. So we just use the formula for the probability. Then at least 3. So we say at least 3, we can consider the opposite side. X at least 3 larger than equal 3. So equal 1 minus x less than 3. Just the opposite side. So less than 3 can be x can equal 0, or x equal 1, x equal 2, right? So here we just need to check 3 cases: x equal 0, x equal 1, x equal 2. So we can apply this formula: x equals 0. Like there's a good thing happen 0 times, bad thing happen 10 times, or happen 20 times, just like that, right? Okay. So then we say, like, if we want to find exact at least, oh no, sorry, no exact, at least 10 questions correctly. So here we want to find at least 10. So we say at least 10, we have can be 10, 11 until 20. And certainly here we also can consider its opposite side, less than 10, right? So less than 10 can be 0, 1, 2 until 9. But we find in this situation, both sides are too many cases. So both sides is not so simple. So the question is how to deal with such a situation. Sometimes we do want to find those probability. Like if I set the larger than at least 10, if you get a 10 question correctly, I let you pass this exam. So we say such a problem is just such a, we can change such a problem as just a probability for passing exam, right? So sometimes we have some interest in finding those things. So how much chance I can pass the exam without any study? Or I have how much chance I can get certain grades, at least certain grades, at what percentage? What is how much chance, right? So for such a problem, if we use binomial distribution, then we say this calculation is tedious. So how can we solve such a problem? So we need to use some new method. Okay. So there were new methods. So let's consider this. So let's say use computer. Actually, we can find those probabilities. Okay. So here, n equal 20. We just try 20 times. P equal 0.25. So meaning the P just equal 1/4, right? So this is just the this problem just like pick our answers by randomly picking our question. This quiz have 20 questions. Each question has 4 choices A, B, C, D, right? So each question you can answer correctly is 25%, or 1 over 4, right? So actually from computer we can find those probabilities. So by the way, from here we can find this x equals 5. You can get 5 questions correctly. Such a probability is highest. And this 5, we say is highest, most likely, right? So highest probability is most likely. So this number actually is mu, or x, or we have the formula for mu for binomial distributions in P. So here n equal 20. We just try 20 times. We have 20 questions, and P is 1 over 4, right? So this number is 5. So we can say from the graph, we can say you can answer, or you can get 5 questions correctly. Such a probability is high. So we want to find x. What is the question we want to find? We want to find x at least 10, right? So this means, so from this part, 10, 11 until 20. So we say by computer maybe such a problem is not so hard, but in this class we do not use a computer. We prefer we just use pen or hand, use those basic tools to solve those problems. So how can we do that? Okay, so we just use approximation. We say, okay, so for these distributions, we find this distribution looks like that, right? Okay. So we just use these curves to approximate those binomial distribution. This curve is, in terms of distribution, this curve is a continuous distribution. So here we can say we just use a continuous distribution. Use this curve to approximate this discrete distribution. Okay. So the most important continuous distribution, distributions just like this one. So this one is here is highest, and the both sides goes down, right? Goes down on both sides. So we call such a distribution as normal distribution. So because many things should look like that. Right? Most people just on the average, and a few people so very high, very short, right? So on both sides should be have few people on both sides. So we call those the normal situation, right? And we call this normal distribution. So for normal distribution, we have a typical notation. So we use the notation. We say x follow a normal distribution. So n here, n stands for normal. So for any distribution, we have mean and variance, mu and sigma square. So mean, this mu is mean, and this sigma square we call variance. And so this sigma square, so this sigma, so this sigma, we call this standard deviation. Okay, so we call this sigma the standard deviation. Okay, so for normal distribution, we put for sigma, not sigma square. Okay, so we just denote this x, this x for a normal distribution with mean this mu, and standard deviation is sigma. Okay, so what is so these are some graphs for normal distribution. So this mu is mean. So we also call this the probability the highest point. Mu, this mu here, this mu here, and mu is also we say the cent. Mu is the cent. And what is sigma meanings? So we say sigma or variance sigma square. So variance changement. If those numbers changing a little bit, changing very small thing, most of the numbers just concentrate on the center. So this cause means sigma is small, and this one means sigma is big. So if sigma is big, that means those numbers are changing very much. So we know this mu is cent. So how can we explain this sigma? So here we have these rules for sigma: 68, 95, 99.7 rule. So what this rule says? This rule just say so here this is mu cent. So from cent, if we just extend one sigma, then this part count for 68%. So if we extend 2 sigma, like from the center, let's send from here, extend to sigma. So from here to here is 2 sigma is count for 95%. And if we extend 3 sigma, then from here to here count for 99.7%. So we say outside almost 0, 99.7 numbers of people in this range. So now we say many things follow normal distribution. For example, like for our height of people, or weight of the people, or exam scores follow normal. Most of the people just on the average, right? So on both sides, few people on both sides. So let's say, suppose this x, this x denotes the height of people. So we know this. So the x follow this normal distribution. So this first number means mean, so 5.8. So we can understand it as the 5.8 feet. So this is average height of people. And point 2, this is standard deviation. We can understand this as standard changement among people to people. The height just changes point 2. Okay, so based on this information, so we can claim like, okay, so we say we have 1 sigma is 68% people will be in this range, like 5.8, so extend minus sigma minus 0.2, okay, and plus, like it just extended 1 sigma, right? So here center is 5.8. So if we extend 1 sigma, okay, so sigma is 0.2, right? So this range is like 5.6 and 6.0. So we can claim like there are 68% people, their height will be between 5.6 to 6.0 feet. Okay, so this is 1 sigma. So 2 sigma, so let's say 1.2, 1.2, so here 5.4 and 6.2. Extend 2 sigma. So we say they have 95% of people, their height between 5.4 to 6.2. Okay, so this is the 1 sigma, 2 sigma, or 3 sigma, or 68, 95, 99.7%, meaning this rule. Okay, so if we just extend 1 more sigma, so here's 5.2, right? 5.2 and 6.4. So in this range, 5.2 and 6.4. So there are 99.7% people, their height will be in this range. Okay. Okay. So out of this range, almost 0.7%, right? So outside is very, very few. Okay. Okay. So if we have a normal distribution, then we can find the probability. Now, if we know the distribution, we can have a probability. So we say distributions put many probability together. We have a distribution. We have a table. So from the distribution, we also can find a probability. Just check this part, check this, right? Okay. So now for normal distribution, so how can you find those probability? Like suppose something follow normal distribution. Follow normal distribution, like okay. And the mu, this sentence mu. Okay. So what is the probability of this part? Let's suppose this is a, like x larger than a, or what is the probability between these two? What is the probability in this part? Like we can, like for people's height, so we can produce many problems. Like, so what is the probability that what percentage people their height is larger than like 5.6 or less than 5.9? We can have those kind of problem, right? Okay. So we have many normal distributions. So we just check the simplest normal. So simplest normal, we call simplest normal as a standard normal. Okay, simplest normal, standard normal. So a standard normal is mean is 0, but the standard deviation is 1. So why we pick a mean is 0? Because we like a 0 is like a simplest number, right? So mean can be there here, mean can be any number, so we simplest number is 0. But here standard deviation we cannot put 0. Let's say can we have this normal? The mean is 0, but also standard deviation is 0. So if standard deviation is 0, means no change. Change means is 0, right? So everyone is 0. So suppose like we say our exam scores follow normal distribution like this. Mean 85 is average, 85 average is 85. So should have some changing mean. So if I put a changing mean as 0, so this means everyone's score is 85, 85, 85. No changement at all. So for such a situation, we say this situation is too simple, right? Too simple. Oh, okay. So too simple. We have no much interest for those kinds of distribution, right? Because no change. So if no change, then we can know the information exactly. So we don't need to consider that. So for this reason, this mean, as we say, sigma usually cannot be 0. Okay? If sigma is 0, means no change. Okay. So for this reason, so we just pick the sigma as 1. Right? So the 1 is simplest number besides 0, right? Okay. So for this standard normal, we want to find those probabilities. So how can we find those probabilities? We need to check a table. We call this table as Z table or no standard normal table. Okay. So here is this such a table, standard normal distribution table. So this table give us the probabilities. So this table give us some probabilities. So if you give me a cut point, like okay, so here this is the normal distribution. So here set is 0. So if you give me cut point, like let's check this number. Okay, 1 point. So let's check. Suppose it's 1.23. Okay, so we have a cut point. Then this table give us this probability for Z less than this cut point. So give me this part. Okay, so 1.23. Okay, so 1.2, so we just check 1.2, then 3 is here. So 1.23, 1.20, 1.21, 1.22, and 1.23 is this. So this number, no, 8907. 8907. So means this part probability less than 1.23. Okay. So this is such a normal table can tell us. So from the table we can say all the cut point is positive number, no negative number. So why is there no negative numbers? No negative cut point? So the reason is normal distribution is symmetric. the positive, negative are symmetric. Okay. So for negative number, let's say like here negative number. So we can check its symmetrical point, a positive number. Okay. So based on this table, we can find any probabilities related to standard normal. Okay. So let's check some examples. So here we have, so there's a problem. X follows standard normal. Then we need to find those probabilities. Okay. So for this one, so let's say for A. So for A. So the cutoff point is 1.12. So this probability, we can check this probability directly from the table. So we just check 1.12. Okay, so 1.1, 1.12. So 1.12 should be this number, right? So first the column is 0, 1.10, 1. Yeah, this is 2. So this number is 86. So we know this probability equal 86. Okay. So how about B? So B, let's say B is this number, negative. Yeah. So we want to find this probability. So here's 0. Okay. And the cutoff point is here, negative 1.32. Okay. So what we want to find is this part is a probability, right? Less than negative 1.32. So we say in the table, no negative cutoff point. So we have to check a positive. So let's say check a positive number, 1.32. Okay, check a positive. Okay, but the number or the probability given from the table is on the left side. But we want to find this probability, so we say this probability, okay, and this probability based on the symmetrical, those two probability same, right? So like this part less than negative 1.32 and larger than 1.32, positive 1.32 the same. So we know this probability should equal 1 minus this is probably left side. So for left side, we can find this number left side, this number from the table. So let's check positive 1.32. So 1.32. 1.32, I think it's this number, right? 9066. Okay, so we know this probability should be minus 9066. Okay, so here we need a little bit of calculation. Okay, so this also this table give us, remember, give us left side, right? This a z less than or equal this cutoff point z. So for larger than or larger side, like this problem, x larger than says 6.68 larger than. So we need to use, so here let's say 0.68. So we want to find larger than this part. So we say larger than is just the 1 minus less than, like 1 minus the left side. So the left side, we can check the table directly. So we just check 0.68. Let's say 0.68. Go back to 0.6. Okay, 0.6. 0.6 here, 0.6. Okay. Which one is 8? I think, yes, this one. Okay. See this one. Okay. So this is 0.68. This number is 7517. Okay, so this over probability should be 1 minus 7517. Okay. Okay. So we a little bit of calculation here we needed. So this equals 0. Okay. Here's let's see. Here's 3, 8, 4, 2. Yeah. So 0.2483. So then, how about D? Now between these two numbers. So between these two numbers, let's say okay. So both of them are positives. Here's 0.54. Here is 1.38. So we want to find the probability between these two numbers. Okay, so because 0.54, 1.38, both of them positive. So we just check, okay, so this part equal the probability less than 1.38 minus less than 0.54, right? So we just equal probability for 1.38 minus the probability, so left side of this part, right? Just probability less than 0.54. So let's check 1.38. So 1.38, 1.38 is 1.38 is this, right? So 9162. So equal 9162. So minus 0.54. So we just check 0.54. So 0.54 is this number, right? 7054. 7054. So just the minus 7054. Okay, so we just a little bit of calculation, so we can get a final answer. Okay. So for E, E is we want to find the probability that between these two numbers, so one is positive, the other one is negative. Okay, so yeah, it seems we want to find the probability so here's 0, right, between negative 1.32 to positive 2.18. So we want to find the probability in this part. So we find that this probability is less than 2.18, so that's all the way down, but need to minus this part. So let me changing the color. So let's say minus this part, right? Okay. So 2.18, so we can find this probability selected from the table. 2.18. So let's see. 2.18. 2.18 thus 9854. So this is 2.18. Yeah. Okay. Yeah. So 9854. So that's equal 9854. But this 9854 is all the way down, right? So we need to minus. We need to subtract this part, the less than negative 1.32. So how can we find this negative 1.32 less than negative 1.32? So we say we have to change to positive 1.32. So we say less than 1.32 is just larger than less than negative 1.32. Just check here. Yeah, check here. We say less than negative 1.32 is equal larger than positive 1.32. Larger than 1.32 is equal 1 minus this part, right? So this equal 1 minus. So we just check positive 1.32. Okay, so positive 1.32. 1.32. We already checked it. 1.32 is 9066. So the probability is like this, 9066. Okay. Okay. So then here a little bit of calculation here. Okay. So we say so from this Z table or standard normal table, we can find any probabilities related to standard normal. Okay. So then, how about a general normal? And our original questions, how to find? Let's go back. Our questions, how to find solve those kind of problem, right? How to find this problem? Like, what is the chance? Okay, that you can pass the exam. Okay, so we leave this question for next class. Okay, so today's topic is in order to solve a binomial distribution problem, we use normal distribution. Just like this picture for binomial distribution for this discrete situation, we just use such a curve to close this binomial distribution or to approximate this binomial distribution. So such a curve is normal distribution. Okay, so for simplest normal or standard normal, we know how to do those problems, how to find the probability from standard normal. So then we have such a question: how can we find probability for general normal, and also finally how to solve those kinds of problems? Okay, so we say those will be our next class topic. Okay, so we can stop here, and thank you